Hi to everyone out there. I hope you're all doing well. This is a quick video to follow up on my mini-lathe upgrade series. Unfortunately, there's not a whole lot of action in this one. It's a bit more of a show and tell. Even so, it should be interesting to some. If you're a new viewer to the channel, or you didn't see the mini-lathe upgrade series, then you might want to catch that first. At this time, I don't really have any proper project for my mini-lathe, but I still wanted to make something practical to give it a bit of a realistic test. So I dug out this knurling tool I'd got from AliExpress quite a while ago. It was delivered in this rather tattered package and two of the main pins had been lost. So I decided to make those pins from this 200mm long, 30mm diameter steel rod. First I cut off a shorter piece using the lathe. You can see here I used a parting tool to cut down about 4mm before giving up in frustration. And then I switched to using this reciprocal saw, spinning the lathe at the same time, and finished the cut. Actually, this worked out to be a pretty good method, and it's pretty quick, and it results in a nice cleanish cut, so I'll definitely use that again. After that, I went on to machine the pins without any problems. So here's the only pin I received in the original package. You can see it there. And here are the two pins that I machined. I think they look pretty good. I also made some haphazard effort to harden them a bit by heating them to red hot and then dropping them in some motor oil. This gave them this nice darkish colour. I did not temper them, so there's a chance that they might fracture when I go to use them. But we'll see what happens. Unfortunately, when I went to use the knurling tool, I discovered then that the body of the tool is so big that I have no way to mount it to my lathe. Anyway, this is a problem I will address on another day. So for the initial verdict on the upgraded lathe, well, I found it pretty easy to use, with nothing software or power-wise that really annoyed me. I was able to machine down this relatively big piece of steel stock into these small pins pretty quickly, so I think that shows me some clear improvement compared to the old motor and controller. Now, if there's anything negative to report, it's that the tool rigidity and my quick change tool post was really starting to annoy me actually. Now, I saw a good video recently on the channel The Radio Shop. Now, that's a great YouTube channel name, that's for sure. Anyway, he shows how to do a long bed upgrade for the mini lathe just a couple of $100 later, and it seems actually like he did quite a lot of work, but it definitely works out to be a nice upgrade that I wouldn't mind to have, but it's probably unlikely I can get it here in Japan, so whatever. Anyway, the reason I bring this up is because at the end of the video he discusses how the aluminium button-style quick-release tool post he is using is absolute garbage, which is in fact the same tool post that I'm using, so that sort of explains a lot. In short, he suggests using the quick-release tool post made from steel that uses side gibs instead, and doing so should improve the tool rigidity and tool height repeatability. So I was sold on that. So after $45 later and a few weeks wait, this arrived from AliExpress in pretty good condition. It's packaged in a good way. There was just one problem that I'd faced, and that's that all of these tool holders that I have, and I have about 10 of them, don't fit this tool post. Yeah, that's great. So I probably should have checked that. So again, this is another problem for another day. So for now, I'm going to switch back to using the simple tool post that originally came with the mini lathe, this one here, and that should at least return some of the rigidity back to my lathe. I also went through and tightened up all the slides the best I could, so I think it's just about as good as I'm going to get it. Beyond that, I see some people removing their top slides altogether, but actually I like to use that top slide for tapering and some other fine work, so I don't really want to remove that. If anyone has any other suggestions, I'd be happy to hear them. So just leave them in the comments. I'm sure you will. Okay, so let's move on. As mentioned in a prior video, the plastic gears in the headstock seem to be causing a weird vibration that resulted in a pretty good galloping shake at some speeds. Apart from being annoying, this can be so bad that it must be affecting the finish of the cut. It's really not good. I also have this picture burned into my mind showing the original plastic gears being totally destroyed. I guess this type of destruction could be caused by abuse, but regardless, there are plenty of images on the internet showing this type of damage. So I guess it's a pretty common failure that I personally would prefer to avoid, especially in the middle of a project. So another order for AliExpress, $25, and a few weeks later, the metal gears did arrive. Packaging was pretty much consisting of this plastic bag, which you can see is nice and damaged, not much else. And a number of the teeth were banged up quite a bit. but nothing that couldn't be knocked down with a file easy enough, so no big drama. First step was to install the large gear, but I found it had a lot of left to right movement on the shaft. After checking, I found the new metal gear was about 2 millimeters narrower than this original plastic gear. This was easy enough to fix. I just printed two 1 millimeter thick plastic spacers. In fact, there are already plastic spacers on either side of this gear, so it's no big deal just to add some more spacers to that. And while we are looking at these plastic gears, I did do some measuring to find out if I could find any problem with the outer diameters that would explain that weird vibration. And there was nothing really weird. However, I did find the inner diameter of the large gear is about 0.5 millimeters oversized. Now, different to the smaller gear, which needs to slide around to change gears, the large gear is simply locked in place on the shaft, so there's really no good reason for such a large tolerance. I think what was happening is that as the speed of the main shaft increases, the rotational forces push the key outwards, forcing the large gear to be off center. That would explain why the vibration becomes more prevalent at higher speeds. Anyway, let's go back to the metal gear installation discussion. After completing the gear installation, I found the low gear ran pretty good, but the high gear was generally pretty tight and would effectively even lock up in certain locations. So that's not a good situation to have. To fix this, I ended up spending a good part of the day trying to identify the problematic teeth and filing them down until I could achieve a somewhat free spin. I can tell you this was not an easy thing to do, as I needed to file down the teeth while they were still installed in the headstock. And I don't think the result is perfect, but it's more than acceptable for me. And honestly, I'm just relieved that I got the thing to work as good as it does. So that's another frustrating, but not really unexpected or unique experience with an AliExpress purchase. I'm sure you will experience much the same. Possibly I could have tried to address the problem through the AliExpress dispute system, but this is always such a huge battle and a great waste of time most of the time. So for this one, I simply decided that fixing it myself was the best option. So to sum it up, I can confirm that the metal gears have gotten rid of the weird galloping vibration, but the metal gears do make a more annoying metallic sound compared to the plastic gears, with the high gear specifically noisier, likely due to the misshaped gear teeth. I guess the noise is not really that surprising. I mean, they are large teeth metal gears with no active lubrication. Possibly this noise will reduce over time as things sort of wear in. I guess you never know. We'll just wait and see. So I'm not ready to make a final judgment on how good these gears are yet, as I haven't had really much time to use them. But so far, I get the impression that it was at least a project worth doing. So now on a different topic, but related to the gear swap out. After the first installing the metal gears, I decided to run the lathes for a while to try to wear the gears in a bit. Unfortunately, I'd messed up reinstalling the gear change lever. This meant that the gear lever was not locking into its ball indents correctly. So after about 5 minutes of running, the gear lever attempted to switch itself into the high gear, causing everything just to lock up suddenly. A second or so later, I heard the nice little pop, and then the controller detected the saw and stopped, followed by the power supply then continuously shutting itself down and restarting and continuously doing that. Very good. So what had happened was that one or more of the MOSFETs in the ESC had apparently shorted out. It was only after the ESC initialized that it would attempt to apply the brake and using those MOSFETs that had failed. In this case, that causes the power supply to detect the short, and then it just keeps rebooting itself. Now, the stall sensor in my controller did actually work. However, it's obvious now that 3 seconds for the timeout is too long. I will definitely be changing that setting in the future so it's as short as possible, but obviously without being annoying to create unwanted stoppages. So to fix the problem, thankfully I had a spare ESC on hand just for this type of situation. So I went ahead and installed the new ESC, turned it on, and it immediately went nuclear, and for no particular reason, burning up 6 MOSFETs and releasing copious amounts of magic smoke. It looked exactly like a smoke machine was being used at the bottom of the lathe. Well, I guess it's a pretty cool effect if you like that type of thing. So here you can see there's a big hole that's been burned in the side of the ESC's case, and here's a view of what it looked like inside once I took the cover off. Here I have 3 boards with the MOSFETs now removed, but it gives you an idea of just how hot things sort of got. You can see it's burnt pretty deeply. So with my spare now dead, all I had on hand was the first ESC that I'd originally ordered, which had a known problem. And while that sort of works, I didn't really want to be using that. So what to do? Purchasing a very expensive ESC probably would solve the problem. But there's also the risk of the same thing really happening again, and that's going to get expensive pretty quickly. And when you think about it, spending hundreds of dollars on an ESC is not really a good fit for the original goals I'd set myself for this project. So with minimal confidence or hope, I decided to take all of these ECs apart and see what I could learn. Now this turned out to be a more interesting and positive experience than one would typically expect, actually. And even though the original problem appeared to be terrible thermal management design of the ESC, otherwise, when I looked at it, I found the ESCs designed to be modular and pretty simple. So actually that was a big plus. This meant you could actually have a chance of understanding of what's going on inside them, fix them, and even customize them. Now I'm planning to make a separate video on this ESC, but for now, here it is, the ESC which I've rebuilt. The short take is that I've redesigned the thermal management and the general packaging arrangement. You can see that each MOSFET board has now been fitted with its own dedicated heatsink. I also checked and reinstalled every single MOSFET to make sure they all work, have similar functional characteristics, and are soldered properly to the board. So far this modified ESC appears to be working pretty well, but only time will tell if I've really fixed the problem or not. As the size of the ESC has now increased more than threefold, that required me to redesign the mounting arrangement for the ESC and sensors in the motor compartment. I guess third time's a charm. So I 3D printed a bunch of new parts, as you can see here. Now I've only been 3D printing and designing for about a year now, but it's still amazing me just how cool this stuff is. You can see this is a pretty complex arrangement with small tolerances, but it all just works really nicely. The ESC is no longer attached to any stays and instead sort of just sits up against this platform. To stop the ESC or cables contacting with the fan, I've made this little protective cage that extends from the platform and is also restrained here at the top. You can also see how the temperature and speed sensors are attached to the platform here and here. I've also moved the connector for the speed controller so that it actually is on the top of the board instead of the underside to improve the clearances. Now this is future me. Being very optimistic, I'd already recorded the outro in advance, just expecting to insert some shots of the lathe running. I should have known better, but during assembly and testing, the ESC managed to fry itself again. So I guess time did tell after all, and it told me pretty quickly too. You can see here that two MOSFETs have let out the magic smoke, so I guess we can now conclusively confirm that this is not just a thermal management problem with these ESCs. Looking to the positive side, I had already built up a spare MOSFET board, which was easy enough to swap out. And the damage was also isolated to this one board alone. So that's 2 successes, 1 failure for the ESC rebuild. And as they say, 2 out of 3 ain't so bad. As for the failure mode, in most cases, the ESC has died when there has been some type of upset. If I'm just using a lathe normally in operation, including causing binding type stalls, it seems to be fine. But I'm pretty sure if I slam the tool into the chuck while it's running, it ain't going to be fine. So beyond the ESC problem, I also noticed in my testing that when I put the lathe into neutral gear position, the motor would barely turn and seemed to be binding on something. So after removing the headstock again for the umpteenth time, I found that the gear changing fork was binding on the race of the metal gear. This is sort of what it looks like in my pencil drawing here. You could actually see a grind mark on the race of the gear itself. So apparently the out of diameter for the race on the metal gear is larger than the original plastic gear. This is naturally worst at the neutral position where the distance to the race is the shortest. It's really pressing here. So to fix this, I filed down this problem spot on the fork by about 1mm, and then everything ran pretty easily enough. Anyway, let's take a look at some machining tests that I just performed after putting everything back together. So that all went well enough. You can see the finish is not all that bad given the old tool I was using, which is probably pretty blunt. Tool rigidity looked good using the old tool post. I didn't push it all that hard, but I still get the impression it was greatly improved on what I was seeing before. Unfortunately, I found that none of the insert type tools that I had recently purchased will work on the old tool post, so that really sucks. You can see here the difference in the tool height. The insert tool is very high, and so much so it's well above the center when it's installed in the old tool post. Now, in regards to using the new metal gears, I found that when running the lathe at speeds over 2000 RPM, the noise is just about intolerable. Definitely ear protection is required. I also noticed the top speed has dropped by about 100 RPM, likely because of the additional mass of the gears. But I can at least confirm the galloping vibration problem has now been fixed, so that was at least one plus. So I guess some of the value of a channel such as this one is for me to experience issues and then share them with you, so you don't have to. So here's a quick summary of my notable recent discoveries. Number 1, don't buy the same ESC that I got. While it has served an educational purpose for me, for most people, it's just going to be a whole lot of trouble. Number 2, don't buy the aluminium button style quick release tool post because it absolutely sucks. Number 3, be careful when purchasing the quick release tool holders, as the dovetail sizes do actually differ a lot. Number 4, these insert type tools do not work with the standard mini-lathe tool posts, so be warned about that. Number 5, if you want to get the metal headstock gears, then be prepared for a huge hassle when fitting them. And also be warned, they are crazy noisy at high speeds. Actually, I would suggest if you are having the weird vibration that I had, then maybe just consider trying to replace the headstock gears with new plastic ones first. Number 6, if you buy the same knurling tool that I got, then make sure you can actually mount that to your lathe, unlike me. So the next video I do will probably be about the work I did with the ESC, likely followed by a few coding videos. I think it all should be pretty interesting, so I do hope you join me then. And if you've made it this far, then thanks so much for watching, and don't forget to like, comment, or subscribe, as this really helps the channel grow. And naturally, thanks to those who already have. So that's it. I'll catch you next time. See ya.